so first we're calibrating the pH meter using a 2-point calibration method. We're submerging the electrode into a buffer solution with a pH of 7, and now we're inputting that into the device. Cleaning off the electrode with some distilled water and blotting it dry. And then we also put in the pH of a buffer solution with a pH of 4, since we are starting off measuring acidic solutions. The meter is now ready to use, and we are first measuring apple juice. Again, just cleaning off the electrode with some distilled water and blotting it dry. The apple juice did have a pH of about 3.5. When the meter is not in use, you're going to store it in distilled water. Next, we're measuring the pH of orange juice, which has a pH of about 3.7, and again, letting the reading stabilize before recording it. Cleaning the electrode off with distilled water and gently blotting it dry, and storing it in the distilled water. This is our hydrochloric acid solution, which had a pH of 0.86. Now we are measuring the pH of sodium hydroxide, which after the reading stabilized, the pH was about 13.15. Next, we measured the pH of acetic acid, which was about 2.6. This is an ammonium hydroxide solution, and the pH was about 11.38. We did have 6 different solutions for this lab, so these are all the solutions labeled. Here we have our table where we recorded the pH of each solution. Again, making sure to blot the electrode dry. Measuring the pH, which was about 5.21. Rinsing with distilled water again, and measuring the next solution. This is one of our lab notebooks that has calculations for the change in the pH. Here we are unplugging the pH meter. And making sure to properly store the electrode back in the solution. So proton dissociation behavior is different depending on whether you have a strong acid or a weak acid. So for a strong acid, there is going to be complete proton dissociation. This means there is no equilibrium because there are only products, which are going to be H+ and the conjugate base. For a weak acid, dissociation is incomplete, which means that some acid molecules are going to remain dissociated, and some H+ ions recombine with the conjugate base to reform the acid. This is what forms the equilibrium. One way to offset this change is by using a buffer, which resists changes in pH when small amounts of acid or base are added, because the buffer will shift the equilibrium to offset the change by absorbing whatever is added.